Hey there, welcome to Imantix AI Academy. This is Asif. Today we'll be talking about quantization, which is basically it's a process wherein a model is made simpler. It so that it can run on lower hardware. The hardware requirements are reduced. It runs quicker and faster. It may not give you the same kind of quality that it was giving earlier and in the larger model, but the responses are more or less similar. So that's what we'll be discussing quantization. Now, what is quantization? Say, for example, we take a number, and the number we take is 1, 2, 3, 4. Now, this number has 4 digits. It points to a specific digit 1, 1, 2, 3, 4. And now what we do is we change this number and we just remove the last digit. We make it 1, 2, 3, 0. Now the difference between 1, 2, 3, 4 and 1, 2, 3, 0 is not a lot. You're losing some level of precision, but it's more or less in the ballpark. Where it would be. You're still in the same range. Now you can bring it down further. You can go 1, 2, 0, 0. You're still in the same range, and you can even take it down all the way to. So what happens in the process of quantization is models, whenever they process data, they store this data as numbers. They store these as numbers in their. It's stored in the model as weights. These are numbers, and what you can do with these numbers is, say I have a model which is storing numbers as floating point 16. It's FP16. So it stores one number as 16 decimal places. And what you do is you bring it down from FP16 to FP8. So you reduce the number of the precision from 16 to 8. Now the size of the model is halved, right? So you say I had a model of 1 billion parameters. The minute you bring it FP8, it comes down to 500 million parameters. You have reduced the size dramatically. The quality is more or less the same. It is still giving you the same general answers. It may not be that precise in the answer that it's giving, but it's more or less giving you something in the ballpark figure. Then you can bring this down to FP4, and you brought it down by 75%. You reduce the size of a model by 75%, bringing it down all the way to FP4. Again, you get something similar in the ballpark, and then you know and this is something that when we are dealing with models, you can make a model faster by using quantization, reducing the precision of the weights that are present in the model. It will run faster and on lower level hardware. You lose quality, and that's why you would say, like, I'm using say Gemma. Gemma is supposed to be a fantastic model from Google. Why is it giving me such basic responses? Because it's being quantized. You are using a lower quality version of the same model. Some people attribute this also to the larger hosting providers. When we lose quality on responses, that yeah, probably we are getting access to a quantized version of the model and not the full version, maybe due to bandwidth issues, or there are too many people using, so they switched us off to a quantized version of the model. Quantization is also pretty interesting from the aspect of data search. So in the world of AI models, there's something called vector search. In the world of vector search, what happens is all the data that you provide to a model, say you take a large PDF of your office documents, or your articles that you have written. You take all of that data, you give it to a model, and you say, try to index this data. So what the model does, it looks at the content that you have given it. It converts that content into numbers. These numbers are a dimension in its n dimensional space. So say I have a room, and it will start putting similar content. It'll start grouping similar content together. So headwear and caps will go in the same approximate location. It'll put footwear and shoes in another location. So it starts storing content in multiple areas and starts giving it these numbers. Now, what happens is, when you're working with these numbers can be pretty large. Sometimes 1,000, it can have 1,000 floating point, components to it. And what quantization helps over there is you can quantize that large 1,000 decimal floating point number vector into a smaller 512, into a smaller, and you can bring it down all the way even just to a binary value. So, and if I'm trying to search, the benefit of this would be, say I have a lot of data. So I start off with my search phrase that find the some particular ruling which was there in so and so document, and I want to know where the document is. So it takes the general phrase, it and starts with the binary version, so it gets a direction in that space, which direction to go. Then it takes the next level and it gets a more finer, a more precise location of where it should search to get that document, and so on till it comes to the final precision as to where the document or where that paragraph actually exists in which PDF and which document, and it gives you the exact answer. So it speeds up the entire process of AI or vector search. The quantization has amazing applications when you are using, when you have to index a lot of data. So someone maybe, who has got an entire library of thousands and thousands of books to index, they could use this quantization process to reduce the quality of the, but you store all of them, right? You store the highest quality version as well as the lowest quality, and you can just drill down further and further based on responses and selection of the, from the AI side, the model will select which it feels is the most applicable version. Yeah. So that's basically it about quantization. Thank you very much.